Morning, chemistry students. Today we're going to be talking about stoichiometry. We've started talking about stoichiometry a little bit when we talked about moles, and we're going to use the mole concept for this process. But stoichiometry is defined as the calculation of quantitative, that means based on amounts, relationships of the reactants and products in a chemical reaction. A couple things you need to know here. The coefficients in a balanced equation tell you the ratio of molecules, or they could also tell you the ratio of moles. And they can be used as conversion factors between different substances in a reaction. So here we have an equation, Mg plus O2 yields MgO. First question you want to ask yourself when you're looking at a reaction is the reaction balanced? And this one, of course, is not balanced, and it should be balanced. And so here's what it would look like if we balanced it. So we'd have 2 Mg plus O2, but there's no number there, so we assume it's a 1. So 1 O2 yields 2 MgO. So the mole ratio of Mg to MgO, let's look at that again. Mg is here, and MgO is here. So this would be a 2 to 2 ratio. I'm looking at the coefficients. Or, of course, you can always reduce ratios, so you could call that a 1-to-1 ratio. And what's the ratio for, let's go back here. What's the ratio for Mg to O2? This would be a 2-to-1 ratio. How many moles of Mg would you need? 2 to balance out 1 mole of O2. So then how many moles of Mg are needed to react with 12 moles of O2? Well, if it's a 2-to-1 ratio of Mg to O2, and we have 12 moles of O2, then we would need 24 moles of Mg. And we can use factor labeling to show that. So for this problem, here's our reaction. We're trying to find how many moles, and if we start with 12 moles of O2, we put 12 moles of O2 over 1 to start. We multiply by a new fraction so that moles of O2 is on the bottom. And then we put our coefficients in here. Moles of O2, there's no coefficient, but that's a 1. That's going to go down here. And then the 2 is going to go here. 2 moles of Mg. Now moles of O2 cancels. Now we have moles of Mg, so we're just going to multiply across. 12 times 2 is 24. Over 1 times 1 is 1, so that's going to be 24, and this is our unit. 24 moles of O2. Okay, so now we know how to convert between mass and moles. Remember, if you're going between mass and moles or grams and moles, you use the molar mass on the periodic table. We know how to convert between moles of one thing and moles of another thing using those mole ratios or our coefficients from our balanced equation. And so now we can convert all of this. We can go from mass of one substance, substance A, to moles of that substance, to moles of a different substance, to mass of that substance. We can also do only one part of the conversion. So for example, you could go from moles of A to moles of B to mass of B. So that would be 3 steps. But we cannot go converting directly from mass of A to mass of B. You can't go directly from mass to mass because if you go from mass to mass, you have to go through moles first. We must always use factor labeling. And so here's a sample problem. So here we have the same equation again, and we want to know how many grams of magnesium are needed to produce 3.05 moles of MgO. So we're going to start with the number in the question, 3.05. Clean this up. So we have 3.05 moles of MgO that we're trying to get. So I'm going to just write this up here so I remember. And then we're trying to find how many grams of Mg. So we want to know how many grams. So we're going to always start with the number in the question, 3.05, with its unit, mole, and its substance. Chalkboard's still wet here. Let's try this again. 3.05 mole MgO. So now when we do our factor labeling, every time we have to show the number, the unit, and the substance because we're working with different substances. So we put this over 1, multiply by a new fraction, so moles of MgO goes down here. Now if we look back at this, it says we can go from mass to moles to moles to mass. But we're starting with moles, so we're starting here with moles of A. Oops. So we're going to go to moles of the other substance we're looking for, and then to mass of that substance. So we're going to go to moles of what we're trying to find, and then we're going to put moles of Mg down here, and grams of Mg on the top. Okay, so here you can see it a little bigger. We have 3.05 moles of MgO, that's the number from the question, over 1. We put this unit here so that it will cancel, and we can go from moles of one thing to moles of the next thing to grams of that thing. So we're going moles of MgO to moles of Mg, and then we go moles of Mg to grams of Mg. Now we need to figure out the numbers that go in here. The numbers for the conversions between moles and moles, just like in the last problem, come from the coefficients of the balanced equation. So for MgO, we have a 2, and for Mg, we also have a 2. Now oxygen is part of this reaction, but because it's not our starting or ending substance, we don't need to include that. So it's not that we skipped it, it's just that it's not necessary to include. So then in our last fraction, we have moles of Mg to grams of Mg. And to go between moles and grams, you use the molar mass from the periodic table. So it's 1 mole. And we have to look up how many grams. So here we are at ptable.com. We're looking for magnesium. Magnesium is here. And the mass of it, the mass of a mole of magnesium atoms would be 24.305. 24.305. And that the unit for that will be grams. That's how many grams are in a mole for magnesium. So back to our notes here. So that's the setup we should have. And when we do the math, oh, we got a new question. Let's figure out what the answer to this one is first. So when we do the math, we're going to take 3.05 times 2 times 24.305. We're going to write that down, and then we're going to divide by 1 times 2 times 1. Before you do that, though, sometimes it's helpful to look at if you can reduce any of these numbers. And I see this 2 here and this 2 here, and I think we could reduce that to a 1 and a 1. In that case, we're dividing by 1 times 1 times 1, which is 1. So if you divide a number by 1, it doesn't change the number. So really, all I have to do is multiply the top at this point. So 3.05 times 24.305, and we get 74.13025. And of course, we'd probably want to round that and get something along the lines of 74.1. And the rule for sig figs for this semester is if you can get it to 3 sig figs, you're good. They're almost always going to be 3 sig figs anyway. Okay, here's another question. I'm going to pause and then we'll do this question. Okay, so in this question, we want to know how many grams of oxygen are needed to produce 152 grams of MgO. So here I've got my reaction written again. We're starting with this number, 152 grams of MgO, and we want to know how many grams of oxygen we have. Now, going back to our little mole map here. We are starting with grams of MgO, so mass of A, that's where we're going to start. So MgO is our A substance. Then we're going to have another fraction that has on the top of it, this thing tells you what's on the top of the fractions. We're going to have one that says moles of substance A, which is MgO. And then we're going to go to moles of substance B. Substance B is what we're trying to find. So we'll have moles of oxygen on the top of that fraction, and then we'll have mass of oxygen on the last fraction. Okay, so here we go. We're going to start with 152 grams of MgO. Make sure you can see me here. And then we're going to go to moles of MgO. And then we're going to go to moles of O2. And then we're going to go to grams of O2. And we know that the previous fractions unit is going to come down here. So this is going to be grams of MgO. Moles of MgO, moles of MgO. Moles of O2, moles of O2. So now to get the numbers to fill in here, we're going to have to think a little bit about how we go between these two sets of units. So moles of MgO and grams of MgO. If you're going for grams, if you're relating grams to moles, you're going to look at the periodic table. So we're going to say 1 mole, and then we're going to get this number off the periodic table, and we'll come back to that in a minute. If you're going from moles to moles, you use your coefficients. So the coefficient for O2 is going to be a 1. The coefficient for MgO is going to be a 2. And again, we don't worry about the 2mg over here at all. And then, if you're going between grams and moles, again, we use the periodic table. It's 1 mole. Then we got to go find the number of grams. So we're almost done with this one, but we got to go look some stuff up on the periodic table. So let's do that. Okay, so we want to know the molar mass here of MgO. So we're going to take Mg 24.305 plus oxygen, which is over here, 15.999, and we get 40.304. Then up here we've got to do grams of O2. Now it's O2, not O, so it's not 15.999, it's that times 2, which is 31.998. Didn't leave enough space there. Okay, now we're going to double check and make sure that our units all cancel out like they should. And grams of MgO cancels, moles of MgO cancels, moles of O2 cancels, and grams of O2 is what we're looking for. So we're ready to do the math. And so we're going to multiply across the top and then divide by what's on the bottom. Okay, so here we go with our calculations. We've got 152 times 1 times 1 times 31.998. That's a big number. 486.3.696. I'm going to double check that and make sure that's right. Yeah, okay. And then we're going to divide that by 40.304 by, 1 times 40.304 times 2 times 1. We can ignore the ones though, right? Because 1 times something is going to be itself. So I'm doing 40.304 times 2, and we get 80.608. And then we're going to divide top divided by bottom, 4863.696 divided by 80.608. And we get 60.3376, we'll just call it 60.3. This is grams of O2. For stoichiometry, you do have to write the number, the unit, and the substance every single time. So 60.3 grams would get you partial credit. 60.3 grams of O2 would get you full credit. So definitely write out the substance as well. Okay, so we're going to do a couple more problems here and make sure we know what's going on. So when you're doing a stoichiometry problem, you should always remember this. In fact, most of the time when students take the stoichiometry test, they write this at the top of their page. Always take a look at your equation that you're given, and the first thing you want to do is balance that equation. So we're going to balance this equation real quick. C is 1, H is 4, O is 2, C over here is 1, H is 2, and O is 2 plus 1, so that's 3. Then, carbon looks good, hydrogen's a problem, and oxygen's a problem. So we always fix hydrogen next. So I would put a 2 here. Whoops, there we go. That gives me 4 hydrogen. It does change my oxygen though, so now my oxygen is 2 plus 2, so that's 4. So to get 4 oxygen over here, I put a 2 here, and that gives me 4. If you have forgotten how to balance equations, definitely go back and look at Unit 1 from this semester and review balancing. So now that we've got our balanced equation, we can start to do some stoichiometry with this. So the first question I want to know is how many grams of CO2 would be produced? How many grams? If we had, let's say, 57.4 grams of CH4. So the first thing we want to ask ourselves is, what's the starting number? Well, there's only one number in the question, so we'll start with this number. So 57.4 grams CH4 over 1 is going to be our start to the problem. Now we're going from grams of something to grams of something else, which means we start here and we stop here. So how many fractions are we going to have? 1, 2, 3, 4 fractions. So we can go ahead and build those up. So there's our 4 fractions. And this mole map is going to tell us what the tops of our fractions will be. So we have grams of CH4. This is going to be moles of that same substance. Moles CH4. And then we're going to have moles of substance B, which is what we're trying to find. Moles of CO2. That's what it's asking for. And then we're going to go to grams of the substance we're trying to find. Grams of CO2. So it's a good idea to set up your fractions before you do any math, before you put in any numbers, just with the units. So grams of CH4 is going to come down here to cancel. Moles of CH4 is going to come here to cancel. Moles of CO2 here. And now all we have to do is figure out what numbers go in each box. So to do that, we're going to say, okay, if I'm going between grams and moles, it's always 1 mole. So going between grams and moles, it's 1 mole. And that's equal to the number on the periodic table. So now I got to look up the number on the periodic table. Well, carbon is, let's just pull up this one on here. There we go. Carbon on this periodic table says 12.011, plus we're going to have 4 times hydrogen's mass, which is 1.008. So that's going to be 16.043. So again, I'm just looking at molar masses on the periodic table for that. Now, if we're going moles to moles, we use the coefficients. So for CH4, there's no coefficient, so that's a 1. And for CO2, there's also no coefficient, so that's a 1. And then in our last one, if we're going between moles and grams, again, it's 1 mole, and the number of grams comes from the periodic table. So CO2, 15.999 times 2 plus carbon, 44.009. So now I have all my numbers in the correct spot and all my units in the correct spot, and I'm ready to do my math. So I'm going to take 44.009 times 57.4, and that's my top number, and then I'm going to divide that by 1 times 16 times 1 times 1, so 16.043 is my bottom number there. And I get 157.459, and again we're going to round for 3 sig figs, so we'll just call this 157. And my unit will be grams of CO2. Okay, I've set us up for one more practice problem. On this one we're going to start with 57.4 moles, remember we started with grams last time, of CH4. And we're going to try to find grams of water instead. So we're going from moles to grams of something different. So we're going to start actually here, moles of substance A, which is going to be CH4. And we're going to go to grams of B, which is going to be water. So in this case, this tells us we've only got a 3-step equation this time. So we're going to start with the number in the problem, 57.4 moles of CH4 over 1. Moles of CH4 goes here. The top of the second fraction is going to be moles of the substance we're trying to learn about. Moles of substance B. So how many grams of water, that's what we want to know. So substance B is water. Moles of water will go down here to cancel. And we'll go to grams of substance B, which is water. So that's our setup. So to go between moles and moles we use the coefficients. So we'll say 1 for CH4 and 2 for water. And then to go between moles and grams, just like grams and moles here, we'll use this. 1 mole equals the number on the periodic table. Oops. There we go. So it'll be 1 mole. And then we got to look on the periodic table to find the mass for water. So that's 1.008 times 2. I'm looking that up on a periodic table. Plus 15.999. And I got 18.015. And if you're looking at a different periodic table than me, you're going to get a slightly different answer, but it's probably going to be 18 point something. So your answer would be close enough, it would be fine. So then we want to double check and make sure our units cancel like they should. So moles of CH4, moles of CH4, moles of water, grams of water is what we're going to get here. Grams of water is what we want, so that's good. So then we do our multiplication, multiply across the top. So, and I get 2068.112. And I'm going to divide that by 1 times 1 times 1, so I keep that number, right? And if we're going to round it for sig figs, we call it 2070 grams of water. Of course, if you had this for your final answer with grams of water, I would not take off points for that. What you would see on a test if it was a multiple choice question would be this number. So you'd have to know, hey, they rounded for sig figs on this. But if you wrote this on a written question or on a question where you submitted a picture, that'd be totally fine. Okay, if you have any questions, come see me in the WebEx. Talk to you soon.